Okay guys, we're wrapping up section 0.7 and wrapping up chapter 0. This is question number 41 and the problem says simplify on page 45. Well, what's to simplify? This is square root of a minus b divided by square root of a all over a minus b. So this is not as simple as it could be. So first I'm going to simplify this top part, the numerator. So we simplify this in order to, because this subtraction here, I want to get them with the least common denominator so I can have them all over one thing here. So I have square root of a. I'm going to multiply this one times square root of a over square root of a. That's times 1, because that way I can put them together because there's a square root of a on the bottom there. Minus b divided by square root of a. So right now I'm just working on the numerator. I'm going to leave this piece alone for a moment. So this equals, look at this. Do you see why I did this? Square root of a times square root of a is a minus b. Now they're both over square root of a. And you might say, how come I can't multiply these together? Because this was minus. So it's, a, this turned into a over square root of a minus b over square root of a. So that's a minus b over square root of a. So the reason we did this is now we have, we'll plug this back in, we have a minus b divided by square root of a, that was our top part, our numerator, times, one way you can do this instead of saying divided by is times 1 over a minus b. It's the same equation, a little easier to read. I get to cancel. You know I love to cancel. Because it's a multiplied here, we can cancel. A minus b, that leaves us with 1 over square root of a. That's simpler, but a lot of people, old school, they don't like a square root in the denominator, so we do this rationalizing the denominator thing, where you multiply top and bottom by square root of a, so this turns into square root of a all over square root of a times square root of a is square root of a squared equals a. I'm saying a lot. Here's the answer, square root of a over a or 1 over square root of a. Rationalizing the denominator. Okay, one more. Section 0.7, this is question number 51, and it says rationalize the numerator. What? Nobody rationalizes the numerator. You always rationalize the denominator, but we can do it. They tell us to do it, we can do it. I always think of these as a little bit like a game, rationalize the numerator, rationalize the denominator. It's a fun game. I'm working on the app right now. I'm kidding. Okay, here's the problem. Square root of x plus h minus square root of x all divided by h. So when they say rationalize the numerator, they're saying we want to get rid of the square roots in this piece. So through some experience, you start recognizing the way to get rid of these square roots is to square it. Well, how are we going to square it? We have to multiply it by, think of this as a minus b, and remember our little rule down here, which is a minus b times a plus b is equal to a squared minus b squared. That's the factoring rule. I think it's called factoring of perfect squares or something. I don't remember the formal name, I just know it looks like this. So in order to get an a squared and a b squared, I'm going to multiply by the a plus b part, which in this case is square root of x plus h plus square root of x. And what you do to the top, you have to do to the bottom. Keep it all balanced and equal to 1 so that you maintain the integrity. So I've multiplied everything by 1 in this fancy form. So now this is like a minus b times a plus b. So it's going to be equal to square root of x plus h, that's h squared, minus, as the a squared, and then this b is x squared, still all divided by h. Okay, and the reason I did this is I'm squaring it so that I can get rid of this square root, and that will rationalize it, make it more rational. Okay, so on top here, this becomes x plus h, because it's square root of x plus h squared is just x plus h, minus x all divided by h. So we have plus x minus x. Oops, I forgot about this part. Times square root of x plus h I was getting excited there. I was like, wow, it's really simplifying. No, it's not simplifying that much. Remember this part? Yep. So h times bracket x plus h plus square root of x. Okay, so on top we have an h, and on the bottom we have an h. Right, so we had x plus x minus x. On top is an h, on the bottom is an h. So this whole thing leaves us with just this bottom piece, which I will rewrite because it looks very messy. So all this is equal to 1 divided by square root of x plus h plus square root of x. So we rationalized the numerator, and so we ended up with these radical expressions in the denominator, which is a little weird, but that is what the problem wanted us to do. Just kind of reverse our thinking. There you go. Section 0.7.